rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Hello, geometers. Today we are doing lesson 1.4 and the topic today is deductive reasoning. And mine is on page 19. You'll need to figure out where your next free page is. And while you all are copying this down, I want to just talk about this lesson because it's a little weird. There are two main parts. One is talking about what deductive reasoning is and then a few other vocabulary words related to logic. And then the other part of the lesson is actually using deductive reasoning to solve problems. And so in this video, we're just going to be doing that second part, using deductive reasoning to solve problems. And then in class, next class, we'll talk about the other vocabulary involved in this lesson. So after this video, you're not going to be able to do your entire homework assignment until we have that other conversation in class, just so you know. So go ahead and turn to your new page, and this is how to set it up. So the date, this is lesson 1.4, and the essential question today is, how do I solve problems using deductive reasoning? I'll give you a minute to set up your notes. And as always, you guys, if I don't give you enough time in the video, please feel free to pause. So we're going to start off today with some vocabulary. The first vocabulary word is bisects. And you're probably familiar with this prefix. Bi means two. What bisects means is to cut into two equal pieces. So cut into two equal pieces. So we'll draw some, well, no, I'll show you now. So here is a segment AB, and I want you to draw line CD that bisects segment AB. So that's what we're going to do. Basically, we're trying to draw a line here that cuts this into two equal pieces. And so it doesn't really matter how we draw the line. We could draw it straight up and down or slanted. What's important is that it crosses the segment right at the midpoint. And I'm just going to approximate it. It looks like it's about right here for me. But since I don't know if that's exactly the midpoint, I want to make sure that I mark up this segment with little tick marks. That shows that this is the midpoint. And then my line CD can go any which way. So I'll just have it go this way. And I need to make sure I label it with a C and a D somewhere. Okay. So that line is bisecting the line segment AB. All right. But then we might have an angle bisector. And it's probably what you think it is. It's something, anything, that cuts an angle into two equal pieces. Whoops. Two equal pieces. And I do want to take the time to draw that because I haven't shown you yet how to show congruence in angle measures. So let's draw an angle. Okay, two rays with a common endpoint. And let's draw an angle bisector. So the way we're going to do that is it needs to go through this vertex. It could be a line. I'm just going to draw a ray here. And what's important is that it cuts this angle exactly in half. And I'm not going to use my protractor to figure out where it would go. I'm going to use markings to show that it's an angle bisector. But I want to kind of figure out about where, like it looks like, I don't know, about there would cut it in half. So I'm going to eyeball it and then draw it. And the way I'm going to show that's an angle bisector is by making tick marks inside the angle. So you create these little loops and then tick marks. And because these each have one tick mark, that's a way of saying those two pieces are congruent. Let's label this up with some letters so we can write some statements about it. We have A, B, C, and then we'll call this D. Take a moment and get that down. And then what we're going to write is that ray BD is bisecting, so it bisects angle ABC. And I also want to take a moment to write a congruent statement. We have two angles here that are congruent to one another, and that just means equal in measure. So this little angle, ABD, angle ABD, is congruent to, and I can't remember if we've talked about that symbol or not, but that symbol is really important. It means congruent to, which means equal in measure. It's congruent to what other angle? You guys figure it out and write it down. So hopefully you figured out that it's angle DBC, and obviously you could flip-flop those letters, and that would be fine. You could have written CBD as well. So that's an angle bisector. One more vocabulary word, and that is a linear pair. A linear pair are two angles, and I'm using my symbol there, with a shared ray that form a straight angle. So I'm going to show you what that looks like here. So that means we're going to have an angle. I'll make an acute angle out here. And we'll call that angle 1. And then I'm going to have a second angle, angle 2, but it's going to share this same ray. So they have to have a shared ray. And then the other ray has to form a straight angle. So my other ray has to be forming exactly a 180-degree angle. So this would be angle 2. And so what I'd like you to write here is that angle 1 plus angle 2 equals 180 degrees because they're a linear pair and they form a straight angle. So that's all the vocabulary. The rest of today's lesson is just about using this vocabulary to solve problems that are going to bring algebra into our geometry work today. So let's get started with our examples. Example 1. There's a lot to write here, so I'll write it and I'll be quiet while you guys copy it down, and then we'll start solving it together. Ray AB is an angle bisector of angle RAT. You're welcome. If the measure of angle RAB equals 3x plus 4 degrees, and the measure of angle RAT equals 10x minus 20 degrees, solve for x. So take a minute and get that down. Okay, you cannot attempt to solve these problems without drawing a diagram. At least I can't, because there's a lot to keep track of. There are arrays, there are angles, there's all this algebra. So the very first step is always going to be trying to draw this. And so I have an angle bisector, and then I have the bigger angle that is getting cut in half. So I want to start by drawing angle RAT. And I don't really know how big it's going to be, so I'm just going to make something up. Okay, so there's an angle. I'm going to make sure that I put the middle letter at the vertex, and then this is RAT. So we'll start there. And then I have to draw this angle bisector AB. And remember that an angle bisector, if you go back up and look at your vocabulary, it's going to cut this angle into two equal pieces. And so I want to try to draw that ray so that it's going to sort of create two congruent little angles inside. And I'm going to mark that by showing these tick marks. Now I can see from my diagram that those are the same. And there's one other thing that I need to include here, which is point B somewhere on this ray. Okay. Then it says if the measure of angle RAB, so that's this angle here, is 3x plus 4 degrees. Well, before I do anything else, I'm going to write that down. 3x plus 4 degrees. Well, that's super sloppy. Hopefully you can do a better job. 3x plus 4 degrees. And then the overall angle is 10x minus 20. So it's kind of hard to draw that. I think what I'll do is show that kind of both of them together is 10x minus 20 degrees. Solve for x. So I just want to think, is there anything else we can mark on our diagram that isn't here already? And I hope you can see that we already know that these are the same. And we don't know exactly how many degrees it is, but we do have information, 3x plus 4. So if this little guy is 3x plus 4 degrees, then can't we agree that this also has to be 3x plus 4 degrees? So I'm going to write that in, 3x plus 4 degrees. And now we have a problem that we've kind of seen before, right? If I add these two angles together, I'm going to get the bigger angle. So I have expressions to represent the little angles, and I have an expression to represent the overall angle. So I can write an equation now. I know that this angle plus this angle equals the big angle. So I'm going to write that down. And one way, I'll use different colors to try to make it clear. So we've got 3x plus 4. That's my first angle. And then my second little angle is also 3x plus 4. And that is going to equal the big angle, which is 10x minus 20. Okay, little angle plus other little angle equals big angle. So take a minute and just make sure that what we wrote makes sense, and we'll worry about solving it in a minute. So at this point, it's just a matter of collecting all of our like terms on one side of the equal sign and then using algebra to solve. So keep in mind that when we're dealing with variables on both sides, first we want to collect all the like terms on the same side. Don't cross yet. So we've got 3x's here plus 3x's here, and that's going to be 6x. And I'm going to go ahead and collect my constants as well. I have plus 4 and plus 4. Which is plus 8. And then I'm going to drop all this down. By the way, if you think you can finish solving this on your own, please feel free to move ahead of me and then just check back in and make sure you got it right. But at this point, we have variables on both sides. Please do not combine them together. You don't have 16x's here because we have 6x on one side and 10x on the other. And we have to give one of these variables the boot. We have to kick it out. And it's usually easier if you use the smaller one. And so I want to get rid of these 6x's. And the way I'm going to do that is to subtract them, because 6x minus 6x is 0. It goes away. And I can do that as long as I do it on both sides of the equal sign. And obviously I'm doing it under the like term. Those cancel. So I have 8 equals 10x minus 6x is 4x. And the minus 20 drops down. And so from here, I can solve, this is just a basic two-step equation. So I'll add 20 to both sides. Actually, I'm going to be quiet. You guys finish solving it on your own and then check in to see if you got it right. Okay. So x is 7, and then make sure, double check you answered the question, and we did. It said solve for x, and we know that x is 7. So there's a lot to these problems because the first step is to figure out how to draw the diagram. To me, that's the hardest part. And then the second step after that is to actually set up an equation and solve. We've got just 2 more examples. Example 2. A is the midpoint of segment BC. AB is 2x plus 13, and AC is 4x plus 3. Find the length of BC. I'll give you a minute to copy that down. So what I'd like you to do right now is see if you can draw the diagram. I'd like you to pause the video, and I want you to draw the diagram, labeling as much as you possibly can. And then go ahead and when you unpause the video, you'll see the answer, so or the diagram and how it should be drawn. So please pause right now. So hopefully your diagram looks something like this. I drew the line segment BC. I've got A as the midpoint, and then I showed that using these markings, and those markings are key. I've got 2 tick marks here, 2 tick marks here, showing that these 2 segments are congruent. And then I wrote the expressions above each segment showing what we know about them. So here, what we know actually is that those 2 segments are equal to one another. And so when I think about how to write the equation, I want to make sure I say this segment is equal to this segment. And I know that because this is a midpoint, and that creates 2 equal segments. And so the equation here is actually pretty simple. We're just going to take our first segment and our second segment, and we're going to stick an equal sign between them because they're equal. And so we solve. Just like in the last example, be careful not to combine these into 6 x's. You have variables on different sides. So once again, I'd like you to pause the video. It's really important that you practice this on your own, otherwise you're not going to get better at it. So get as far as you can in solving this equation, and then if you get stuck, press play, or when you finish, press play to check and make sure you got it right. So I'm subtracting 2 x's from both sides. I'll subtract 3 from both sides, trying to get x alone. And then the final step here is to divide on both sides by 2. X equals 5. And it's super tempting now to pat yourselves on the back and congratulate yourselves for being done, but we're not. Go back up and look at the question that was asked. So it says find the length of BC. And we haven't done that yet. We just figured out what x is. So think for a minute about how you would find the length of BC. So what we know is that this segment is 2 times x plus 13. And so I'm going to come back up here, and I'm just going to replace the x with 5. So I have 2 times 5 plus 13. So that's going to be 10 plus 13 equals 23. And honestly, I don't even need to plug it in here, because if this segment is 23, then this segment also has to be 23. It has to be because they're congruent. So it's asking for the length of BC, so we've got 23 and 23 more. So the length of BC equals 23 plus 23, which is 46 units. And that's our answer. So one more. Example 3. Angle WXY and angle YXZ form a linear pair. The measure of angle WXY equals 3x minus 30 degrees, and the measure of angle YXZ equals x plus 10 degrees. Solve for x. So there are two things I need you to do. I need you to draw a diagram, and you may need to go back and look to see what a linear pair is. And then once you have your diagram totally drawn and marked up with everything you know, you're going to go back and figure out how to write an equation using this fact about linear pair. And I'm going to have you pause right now and get as far as you can through this problem. Again, if you don't try these on your own, you're not going to get good at them. So pause the video, get as far as you can, and then press play to watch how I do it. First step is to draw a linear pair, and I'm going to take kind of a shortcut, and I'm going to start by just drawing a line, and then I'll pick an endpoint here, and I will draw a ray. And that forms a linear pair. I've got two angles there that add up to 180 degrees because it's a straight angle. And then I need to do some labeling. So I've got x is in both of them, and so x has to go there. There are no other options. But the rest of it is flexible. So I'm going to say this is WXY and then YXZ, although those two could be flipped and that would be fine. Excuse me. And then obviously I need to label what I know about these angles. So angle WXY is 3x minus 30 degrees. And then YXZ, this little guy, is x plus 10 degrees. And I'm supposed to solve for x. It didn't tell me anything else. So I've got to go back and figure out where does the equal sign go here? Because I know these are not equal to each other. Well, they might be, but I don't know for sure that they are. So I can't put an equal sign between them. So then we have to think, well, what if we add them up? If we add them up, these two angles, we know what we're going to get. We're going to get 180 degrees. And the reason we add them up to get 180 degrees is because the problem said we're dealing with a linear pair, and that's just the definition of a linear pair. So I'm going to take my two angles, add them up. So I've got 3x plus 30 is my first angle, and I'm going to add that to x plus 10, which is my second angle, and that has to equal 180. So there's my equation. So if you haven't already, please pause and finish solving this. If you set up your equation wrong or you got stuck, take it from here on your own. If you're already done, then you can look up here to see if you got it right. 3x plus x is 4x. 30 plus 10 is 40. So now I have a nice two-step equation. Minus 40. Minus 40. Divide on both sides by 4. Okay, x equals 35. Oh, you know what, you guys? I messed up. We found my mistake. That should have been a minus. So I have to redo all this. Oops. Here we go. We have 3x minus 30 plus x plus 10 equals 180. Sorry, guys. So 4x minus 20 equals 180. This is looking better. Plus 20 plus 20. 4x equals 200. X equals 50. There we go. And that was the question that was asked, so we're done. So at this point, I'd like for us to go through these notes together and think about how to do the key points. I know we're still kind of practicing that. The first thing you want to do in this column is make sure you write all the vocabulary words down. And I'll let you do that on your own. You've got bisect, angle bisector, linear pair. You also may want to think about putting this over there and maybe writing what it equals. And then the rest of this it's just examples. And so you can write example, and then here you can just write really big examples like that. But at the bottom, I do need you to do a summary. So the question today was, how do you use deductive reasoning to solve problems, basically? So we haven't talked about what deductive reasoning is, but deductive reasoning is basically using logic to set something up. So I want you to generally think, like, how did we approach these problems? There were 2 steps that we did, so you want to talk about those 2 steps. And that's it.